So the Bayes theorem states that probability of A given B is equal to probability of A into probability of B given A divided by probability of B. That's what Bayes theorem states. So let's try to prove this Bayes theorem. So here is the proof of Bayes theorem. So from the definition of conditional probability of A given B is equal to probability of A intersection B divided by probability of B, right? So if I rewrite this, this is equal to probability of B intersection A divided by probability of B. So let's say this is equation number 1. Now again, from the definition of conditional probability of B given A is equal to probability of B intersection A divided by probability of A, right? So therefore, if I rewrite this equation by taking this this denominator on the left hand side, I'll have probability of B, probability of A into probability of B given A, which is equal to probability of B intersection A, right? So this is equation 2, right? Now if I substitute this value, that is this value, for this in equation 1, right? So you see equation 1, the numerator is same as this, right? So if I substitute equation 2 in equation 1, what will I get? Equation 1 becomes probability of A given B is equal to, now here I am substituting this, right? So this is equal to probability of A into probability of B given A divided by this denominator, which is probability of B. So which is Bayes theorem, right? This is Bayes theorem. So that is the simple proof of Bayes theorem. So Bayes theorem is extensively used, or it is the main idea behind naive Bayes classifier. So naive Bayes classifier extensively use this Bayes theorem. So we are going to use this Bayes theorem while discussing naive Bayes classifier. So stay tuned for the naive Bayes classifier, which we'll discuss in the next video. So thanks for watching.